My name is Mehran Umerani. I was a former PhD student in Alon Gordetsky's group at the University of California Irvine.
Hi, I'm Preeta Pratakshya. I'm a fourth-year PhD candidate in Professor Alon Gordetsky's lab at UC Irvine.
Hi, my name is Atrouli Chatterjee. I'm currently a fifth-year PhD candidate in the Gordetsky group at UC Irvine.
We formulated a way to recapitulate the properties of a full-length reflectin.
Reflectins are very interesting systems, So like these proteins play a critical role in cephalopods' camouflage abilities, but studying these proteins is inherently challenging.
What we decided to do was to use a multifaceted approach to design a truncated version that would be representative of the full-length protein and would eventually give us insight as to how the full-length protein would fold.
We chose this Reflectin variant, which has only 64 amino acids compared to the parent protein, which is like around 350 amino acids. So compared to the parent protein, this one is more amenable for structural characterization, and at the same time it was easier to produce as well, but we should also note that it is able to capture all of the important properties and behavior of the parent wild-type protein.
Initially, I was involved with more of the protein expression and production side of things, but in this case, not only were we trying to get these high yields and high purities, what the other challenge was that we also wanted to do nuclear magnetic resonance spectroscopy, NMR, on it. And so we needed to get to be able to express this protein with isotope labeling.
I took part in both of the trips to Trieste and Ljubljana. I was mostly involved in the small angle X-ray scattering experiments. There we were able to just identify the general shape of the protein and how it was folding in solution. And then I brought over the protein, the isotopically labeled protein, to Ljubljana and worked with some of the staff scientists there to get an atomic resolution structure. And they were very friendly and helpful in terms of the data analysis and getting feedback and to get next steps forward and kind of troubleshooting any issues that we had.
So from the SAX experiments, we got information first about the size of the protein. So we get something called the radius of gyration. So that tells you literally, how, like roughly an idea of how big your protein is. Then we get information about the shape of the protein.
In most medical imaging or in most scientific imaging, you typically use, fluorophores, you use isotopes, you use some contrast enhancing agent. You use some, additional molecule to be able to visualize what you're interested in. But for reflectins, because of its unique amino acid composition, you're able to visualize this molecule without the need for any other contrast enhancing reagent. And so I think there's a lot of potential there to use reflectins as a jumping point for the development of other label-free molecules for imaging.
We actually showed on the application of a stimulus, we can change the refractive index of this protein. Now, this could have potential for different biophotonics applications.
I think one of the biggest pushes forward is to develop reconfigurable camouflage materials using the protein.